I see Martin and Greg and Harold. We see you there. Haven't heard you say anything yet, but good morning.
Good morning.
So, hey, so a couple of things that I wanted to. Well, I figured everybody probably wants to talk about the CX4 crash accident. So let's talk about that here in a minute. One thing to top of mind, Greg and I were talking or texting us about. He got one of the Harbor Freight pneumatic riveting tools, and he bought it a while back. Anyways, long story short, he ended up having an issue with it. It's not working, so he ended up ordering a new tool. But I was just kind of curious, how many of you guys have any of those pneumatic riveters, be it Harbor Freight or another company, and what's your experience been with them?
You're talking about for pulling rivets?
Yeah, for pulling. Yeah, I'm sorry, not a.
That red one in the lower left-hand corner.
Yep.
I'd have to look and see what brand mine is. I don't even remember. I bought it through Zenith.
Okay. All right.
If
I don't mind asking, what was the price through Zenith?
I was just going to go look.
Remember?
Yeah, I don't remember. It was probably 10, 12 years ago when I was working on a 750.
Well, it was probably half price of what it is today then.
Yeah.
Yeah.
They're on the Amazon, they have a variety. And there was one there for about $75 or something with 2,600 pound pull, it said. The recommendations on it, 5 stars or 4 stars, were pretty good.
Okay, so what is the go-to size / force needed? I've never done one of these.
I don't know what the force is. And
yeah, I guess I'm not. That's a really good question, Alan. I guess I'm not sure on what's required. I know. So I use just a Harbor Freight one of those. I think the list price is like $40. You go get your 20% off coupon and get it for whatever, $30 or something.
Got
like
2 of them on his bench.
Yeah. So here, let me pin his video here for the recording, and let's see here. Okay. Yeah. But yeah, I guess I haven't looked at the pressure. I know there's some adjustments you can make. So with the actual air pressure, you can reduce the air pressure to get a different pull. You can, and there's some other mechanical adjustments that you can make. You can use a different size tip on it to get different effects, that sort of thing. I guess what I've looked at is the size of on the back side of the pulled rivet where it expands, looking at the size of that to make sure it's sufficient to hold.
Can you read that?
Hey, Martin, have you used the
ETD? Okay.
rivets that are the recessed rivets that fold over?
Recess. Are you talking about Zenith?
Zenith.
Yeah, they use a conventional countersunk rivet.
Right.
And then they have the concave tip that then rolls over the edges of the countersunk to make it look kind of like a domed rivet, so it gives you a little more of a gripping or pinching. Compresses it like 2 sheets of the string together tighter.
Well, the head is also a little flatter, is it not?
Yeah.
Not as much dome.
It's supposed to be a little bit flatter than if you just use a conventional dome, surface rivet.
I just posted the link to that Zenith riveter in the chat here. And yeah, I believe that the heads on it, instead of being flat like some other ones, they actually have a little bit of a convex dome to them, right?
When they're pulled, they have the dome.
Right.
But it's a recessed rivet that they use.
Right. They start out with a flush countersunk rivet that you'd normally dimple the skin, but instead of dimpling the skin, you just use a normal rivet, and then when you squeeze the rivet, there's the tip on the rivet gun is got a concave end on it, so it kind of forms that flat countersunk head down to make it look like a low profile dome head.
Interesting.
And I didn't get to use it much on mine, but I helped them build the 1 Week Wonder, and I helped them build 2 sets of wings at Oshkosh. So I pulled a lot of rivets on 3 different sets of wings in 2 years.
Martin? So,
Yeah.
Martin, so it's the idea that you've got something that's flatter than a conventional dome without having to go to dimples? Is that the concept?
Yeah. I never measured it to see what the exact dimension is. I mean, it appears to be, on the speeds that the CXs fly, I don't think it's a real big deal whether it's flush or not. Van used to say that on the RVs, unless you're over 150 miles an hour, don't worry about countersinking. But, some guys just like it because it looks nicer, or they don't.
It's a lot of work.
Yeah. I put the link to both the riveter and the rivets in the chat. So if you want to go look at those.
Well, I've followed Chris Hines ever since back in the 60s. He was an aeronautical engineer in Europe and worked on the Concorde and various things before he got into the home builds. And I was thinking of buying one of his CH-200s and test flew it back in California in those days. And I got a lot of respect for Zenith and his production.
Mm-hmm.
If you can see it, but this is a threaded tip that goes in the end of the rivet roller. And all they do is machine a little concave on the end, and that's what basically forms the dome. So if like I said, if you start out with a conventional pull countersunk rivet, and then as it's being pulled, the head gets pulled up into that counter or concave tip, and then it just wraps the edge down onto the skin.
So the reason I'm asking these questions about that is, and I realize I may be totally going down the rabbit hole, but I really have a real love for polished aluminum airplanes with flush rivets. Maybe that's too many visits to Udvar Hazy. I don't know. You can go up and, if you wanted to, you could touch some of the airplanes, and there's a DC-3 that's just beautiful. Anyway, so I also understand this airplane may never get finished if I do that. So I expect what I'll end up doing is some experiments using the Zenith, using flush, using straight, and then have a long period of searching my soul.
Yeah.
Yeah, if you want to have
Appreciate
an airplane with a polished skins and stuff, none of my aluminum, of course I bought it from had available with this plastic protector on. But if you want to do a polished airplane, I'd recommend getting aluminum that has the plastic protector on, like Van does on his kits, because it sure stays on the wear and tear and scratches that you have to try to buff or polish out later.
I'm sorry, Martin. There was some extra noises. What were you recommending?
If you can find a source for your aluminum for your skins that come with the plastic protective coating on it that you peel off later.
Right.
That saves a lot of dings and scratches and stuff if you're going to polish your plane later on.
Got it. Yes.
I think most of what you order from Aircraft Spruce or Wix will have that on there. If you order from a local source, it may not. But yeah, you can double check that with them. I know I order most of my thin sheet aluminum, which is what skins are made from Aircraft Spruce, and everything I've gotten has had at least one side protective plastic, if not both sides. So.
Oh, yeah. The last time it's been a few years since I ordered from them, but I've never gotten plastic from Aircraft Spruce or Wix in the past. So,
Okay.
For that, or?
Not that. No, it's. I don't know, unless there's multiple. Let me go over to Aircraft Spruce and just see if there's multiple options for the sheet. But let me take a look here.
That's definitely the way to go. Then I didn't realize they did that now.
Yeah, the last couple of years, I don't think I've gotten any from Aircraft Spruce that hasn't had that, and I don't order much sheet from Wix just because the shipping price is a lot higher. Yeah, so if you go to 6061 T6 bare sheet, let's see here. And okay, and then do they have bare sheet? Yeah, and then they have all clad sheet, which is 7075. Yeah, so it's just the 6061 T6 sheet, bare aluminum sheet. So that's what I order. Let me go back to my previous orders and just double check that, but I'm pretty sure that's what I've been getting. So
I just put a link to the Zenith construction manual that has all the information on riveting and various and sundry things. It's a good primer on construction.
Got that, Rob. Thanks.
cool. Yeah, so yeah, here I'll just pop this in. But this is exactly the stuff that I order from Aircraft Spruce here. I just double checked in my last couple of orders. So that's in the chat there. It says bare aluminum. I'm not sure why 6061 has, how is it? I'm sorry, the 2024 is pure aluminum, which is why you need to coat that. And then the 6061 has the thin layer of, what's it called on it, right? Or do I have that backwards? I think it's, I think that's right.
Yeah.
6061 is coated.
No, your 2024 is copper. So it has the pure aluminum cladding. If you're going to use 2024, you want to get the cladded.
I don't think you can get 20.
Yeah, 2024 T3, and then
2024 has the all-clad coating.
Right.
Yeah.
The 6061 doesn't have it. He doesn't need it.
Yes, because that's right. Because the alloy through and through is sufficient for protection from some level of protection from corrosion. Yeah. Yeah, this 2024 is more of a pure aluminum, so it needs that coating in order to have.
Actually, 2024 has got copper in it, so that's why you want the extra protection.
Okay. I'll defer to Martin. He's the expert on this stuff here.
No, I just read a lot of material specs.
I'm sure you do in your line of work. So yeah. Yeah. So. Anyways, so yeah, Greg, you got those two pullers there. Can you show us like what the difference is between them? And so for I mean, I won't go into details, but basically the one is Central Pneumatic, so that's Harbor Freight, $30, $40 tool.
Yep, right there.
And then the red one is, was it Aircraft Tool Supply or something?
It is Aircraft Tool Supply. It's branded Taylor Pneumatic Tool Company. And this is the one that Dave Thatcher has on the recommended tool list. And it's made in the USA type of thing. And the basic gist of the difference, I would say, is like, okay, for example, I've removed this nose piece off this one. And, you know, both of them in the instructions will say, you know, always disconnect tool from air source before disassembling. You know, that's just a given. And with this, it comes off nice and it works fine. But all of these surfaces right here are like almost like nicely polished, finished surfaces. On this one, I'm not going to take it off right now because I am going to mess it up. When you turn this off, the Harbor Freight one, it comes off with significant friction. This just comes off with a spring-loaded but smoothness to it. And what I found happening was where you gauge the pull length with this thing, and it's very specific in the manual here, it says 71 millimeters, but there's this gauge wrench for both of them. It's on the money. It's exactly right. Now, what would happen with this one is I would take it off, and this distance was like, it was out to here. And then I would readjust it and it would move. And the only thing I can attribute it to is I would say the finish of the parts inside of this one is more like a first pass cut and then assemble it. Now, I'm sure you could take Scotch-Brite or something to the internal parts of this one and make it exactly as good as this one. But this was driving me nuts. I wouldn't be able, all of a sudden, you know, like I had to change the nose piece, and oh my goodness, that took serious oomph and friction and almost grinding on it, I would say. So what I found was the trick with the Harbor Freight one was actually hook it up to air, squeeze the trigger and hold it. So now it's pulling back and there's no pressure against these parts. Now change the nose, now change this thing. And when you, and you know, when it's off, you can let go of it and it comes back out. Then you can do the equivalent of this on this one and get it adjusted right. But then to put this back on, my goodness, squeeze the trigger, get it to retract, and then put it on and tighten it and, you know, get this all arranged. And when it's all tightened up, go ahead and release it and let it come back. That was how I finally could get this one to behave properly. But I think this thing needs a disassembly and a Scotch-Briting of all the internal parts. But that was the gist of it. In the operating instructions, it's a little bit confusing about how you remove the bottom and the oil that you have to fill it with. In the Harbor Freight instructions, oh, and by the way, it says maximum pull force 2,800 pounds at 90 psi. And that's probably just a function of the area versus, you know, and pressure that's on it. But it talks about, on this one, it says fill, you know, you remove this cap, you pull the piston out, and it says fill it to the top of housing 15, which that's this part right here. In this one, it basically says a ½ inch below nut 40. Well, nut 40 comes in through here and attaches this part on. So that would maybe cleared that up a little bit. The instructions for this one were really specific about using a 30 weight non-detergent oil. And this just said hydraulic fluid. And so it kind of left it sort of up in the air. So that's the gist of the difference between the two. $32 with a coupon, and good gravy. This thing was $165.95 with shipping. I paid $180 for that thing, which didn't feel right. But the second I used it for the first time, it was like, oh yes, this is awesome. So that's the gist of it.
Very cool.
Well, there's a
Thank you,
difference in size and weight also, isn't there?
What's that?
There's a difference in size and weight of those two units.
Actually, it's very similar. yeah, I don't know. It's hard to discern a difference in weight. And what's almost scary is the similarity between the two. You know, it's almost one of those situations where the parts all came down the same assembly line. These just got put together. These got shipped off to the US and got polished and put together. You know, the angle of the pull trigger is a little bit greater here than here. So I mean, there's definitely a difference to the internal mechanism, but
Which one's more comfortable?
oh, this one is the beast. I mean, it's incredible. But you know, as far as holding it, you know, it's really just not that much different. But the fit and finish of this thing is outrageous. And like I said, not that you couldn't take it all apart and do that with this.
One thing I was going to say, Greg, you might want to look at this.
Yeah.
I have a swivel fitting, pretty inexpensive, but man, does that make life easy.
Hey, I was wondering about that because I did have one of those that I put on here.
Okay, yeah. Yeah, so I've had those as well. Those work great for some tools, like spray guns and stuff. I like this style for this kind of thing because you're going to be setting it on the bench, and it can like lay flat. I don't know if you can see that. And also it does a total, so it'll go vertical, so your hose can hang straight down. Whereas the one you have, it does have some sort of a give, but it'll still require it to be kind of off to the side, so you'll always be a little bit. But see, like when I'm riveting vertically, it'll switch to vertical. It can.
Oh wow!
Yeah, so and they're $4 or $5. They're not super expensive or anything. But yeah, I like it.
Where did you find that fitting actually?
Maybe Fastenal.
Okay.
I'm not sure exactly. It might have been one of the local, builder supply type stores, Lowe's, Home Depot type thing.
Wow.
But
on this one,
Fastenal.
I just put a straight, I put vacuum caps over it to keep the dust out. But that's just a regular. It's the only thing I had.
Yeah, it'll work just fine. I was just gonna say that I like that. It's really nice.
Well, and
it'll work just fine without it, but it's just it's a kind of one of those, after you do a couple hundred rivets, you'll see if you like it or don't, or if you want to, change it out, and so. Yeah.
And I got to admit, the little bit I've used this one, it was kind of nice just to be able to reposition the hose a little bit. I just didn't have another one of those and just put the straight one on, but I like that idea.
Yeah, gotcha. I'm just looking to see if I can find a link to this thing. I'm not. Let's see here. I'll try to put a link to it in the YouTube video when I post it. So, yes, I know they're around.
Yeah, that'd be interesting to find out about, no doubt.
Yeah. Anyways, well, cool. Yeah, thanks for showing those to us. Cool. Anybody else have any experience with other brands? Or sounds like the Zenith gun looks like it's a little less expensive than that one that you have, Greg. It's about 125 plus shipping, but then it comes with those tips too. So if that's the way you want to go, then you'd have those modified tips. But then I don't know if you'd have to use their rivets then as well or not. But that might be something to look at.
They're just AVEX rivets.
Do you use AVEX?
That brings up an interesting little quick side issue that I can't help but think about again. Is a few weeks ago we were talking about the countersunk rivet angle, the 100 versus the 120.
Right.
And with the Zenith one, they're using a countersunk rivet and then with that head, they press it down, you know, because of that shape of the head. So, you know, here we were talking about a 20-degree difference in countersink angle, and Zenith intentionally uses one that's 60 degrees off. It's kind of, it just kind of reminded me of that conversation, the 120 versus 100 thing, which, you know, I've got the cutters for both, you know, now, but it's really interesting how they're using something that's 60 degrees off and then forming it. And here we were, you know, talking about a difference of 20 degrees.
Well,
It's just kind of interesting.
Zenith Avex is using the 120-degree rivet.
Right, and so that's what Greg's saying. On each side, it would be 60 degrees,
Yeah,
right?
60
The
degrees.
flat. So yeah,
Yeah.
It's kind of interesting.
No, it's 30 degrees. It's 120 included. So.
Oh, is it 120? Okay. Oh, I guess that makes sense. Yeah.
Yeah. So you got 60,
Yeah, you're right.
30 on each side.
Yeah. Yeah, you're going from 180 to 120, so it's a 60-degree difference.
Depends
So
where
30
you
on each
measure
side.
the angle.
Yeah.
Yeah, or a 5-degree difference, or, you know, or 10, whatever.
Right.
I mean,
Well, 100 degrees is the aircraft standard rivets, Cherry Max.
Let's see here. I'm gonna flip to here. Let me do this. I'll flip over to Fusion. We can just draw this up so we're all in the same understanding of what's going on here. Let me share my screen quick. So yeah, what we're talking about would be let's just put up. So this is your surface that you're. Let me blow away that dimension, and we are putting a rivet through it, right, at a 90-degree angle. Oops. So this would be in theory the center line of our rivet, right? So what we're talking about is from that point, there'd be a, oops, that's all I wanted. So 3-inch, 30-degree angle there. Now let's just pick this up and pull it across. So I'm not making this too scientific, but in theory, if this is your rivet head, your head of your countersunk rivet, this would be a 120-degree rivet, right, Martin?
correct.
So this line is 180 degrees from the center point, and this would be 30 degrees off of 180, which would give us 150 degrees, and then the other half would be up another. Pulling this the wrong way.
I just mirror it.
Yep. Yeah. I guess I could have just mirrored it, but basically, yeah. So then your angle here, if we dimension this angle, you're now at 120.
Right.
So we'll just over constrain that, but yeah. Does that make sense?
Yeah.
Versus if we do, you know, this to this is, well, I guess I can't even dimension a single line, but yeah. So the thing that we were talking about before was that this is a couple weeks ago. We were talking about how the rivets that are called out are 120-degree rivets, but the hole is 100-degree. Do I have that backwards? Maybe.
Yeah, an AD rivet countersunk is different than what your pulled rivet head is. So if you use a dimple die that's set up for a normal MS or, you know, 80 solid rivet, it's not the same angle.
Right.
So it was the cutter that comes with the standard countersink thing was 100 degrees instead of the 120 degrees of the countersink of the pull rivets. That was the initial thing that I had asked about.
You got to get 120-degree countersink to use them.
Yeah, so then we have the example of the zenith rivet that is intentionally way further off than that, and they just like mush it down and just make it work. And here we're worried about this little angle. It was just such an inconsistency. That was the only observation.
Right. And then the thought here being 40 degree equals 100 degree rivet, right? So, or 100 degree hole, I guess, as the case may be. So the thought was that if you're drilling a hole with a 120, or dimpling with a 120 degree dimple die, but you're putting a 100 degree rivet in there, is your head going to be wide enough because there's the angle there and that sort of thing,
Right.
or if it's reversed, of course, then maybe your head's too wide and it will actually not be flush now, and then the most important part is simply,
what
Go ahead,
most
Mark.
guys end up doing is they inadvertently use the 100-degree dimpler dies and stuff for their skins, and then they put a 120-degree pulled rivet in there. So then the head of the rivet is actually touching like on the perimeter of the hole.
it would overlap right in this area, right?
Yeah, it's not seating down in.
Bottom line, they're not compatible.
Correct. You're not getting
Yep.
the same contact that you would normally get. So if you really want to countersink and have a nice smooth surface and pull rivets, get the 120-degree dimple dies.
Yeah.
Fine.
Or at least, I mean, I think at the end of the day, it's at least make sure that the rivets you're using match the dimple that you're using, right? And that's
Correct.
that's kind of at the end of the day, that's what we need to watch for. So the reason this came up was, I think, Greg, you were looking at the plans or the builder's manual, and you found that the tool list listed, let's say, the 100-degree dimple, but 120-degree rivet, or vice versa anyways. And so there's some confusion around that. Yeah. So, anyhow.
And at the time, my thought was, okay, the countersink bit has a 100-degree angle, and the rivets have a 120-degree angle. So my thought was the intention must be to let this 120-degree head go into this 100-degree countersink angle so that the rivet forms down in, just like the zenith one is going to go significantly more change in angle than this little bit like that. And so I thought we had a zenith thing going on to make sure that it was truly flush and allow it to just pull down in a little bit further. So that was my initial thought pattern, is are we pulling a small fraction of what zenith does with a huge angle change with just this little itty bitty small change to intentionally make sure it's nice and flush and pulled down in.
Yeah. Well, and the place that these are used, I think the only place that I'm aware of that the flush rivets are used on the Thatchers is in the tail area. There's a bulkhead, and it's where the vertical stabilizer, I think, attaches, right? So there's some uprights.
That's where it shows up. Yeah.
Yeah.
And
So there's rivets basically on both sides, and if you have a proud rivet, if you have a rivet that's sticking out, it's not going to. Those two surfaces aren't going to sit flush. They're going to be raised or separated by the however high the rivet head is.
Yeah, and you'll see some comments out there about the pulled flush rivets not truly being flush. And so that's where I was starting to think we were pulling a zenith with putting this rivet into that countersink just to reform that head like zenith reforms the head, to make sure that bulkhead would fit up flat. And that was just a question.
Mm-hmm.
I do have now both, 100 degree and 120 degree countersink cutters and pull rivet dimple dies. So I can put whatever angle wherever. So that's not a problem, but it's just that initial question was still there.
Gotcha. Yeah, here I'm going to pull up that spot on the plans here in a sec, and so
Solid rivets eliminate the problem.
there you go.
I use them wherever I can, just because it's me.
That's all right. You can do what you want. It's experimental, right? So
I might save a whole half a pound by the time the plane's done.
let's see. Let me share this here. So this is the piece here. Use countersunk BSC 43 rivets below this line. The heads must face forward in order for the fin to rest flat against F12 bulkhead. So this piece is this right here. And so when you mount this, let's see, let me scroll up a little and zoom out a little bit so we can see what we're looking at. So this is the vertical stabilizer spar.
I'm still seeing your rivet drawing.
Oh,
Do a refresh.
Yeah, I've got the vertical stabilizer here.
should be the blueprint. You got it?
Yes.
Okay. So, but anyways, yeah, that's the piece that we're talking about. So when you mount this up, it needs to mount directly to that F12 bulkhead in the tail section. So let's go look at that quick here. Let's see. So this would be the right here, this bulkhead right here, which is actually marked as F11. I think the numbering, I'm guessing that numbering the F12 is probably from the CX5, not the 7. I'm looking at 7 plans. Let's go to the 5 here and just double check that that's correct. Wait for this to refresh. Yeah, so this is marked as the F12 on the CX5 plans. So it's on the CX7, it's the F11. So it's a change. Ellen, you asked about what changes for the CX7. That's one of them. So
I don't think that was me.
what's that? Oh, wasn't it? Oh no, I'm sorry. That was somebody. That was another builder was asking. I think Don Larson was asking about that. So,
yeah, Don's building a 7.
What's that?
Don's building a 7.
Yep, exactly. Okay. I'm just making a bulkhead.
This is ironic because I've actually been closer to a CX7 than anyone else online because I sat in the prototype.
Yeah, I think. There's a few. Greg, I think didn't you go down and sit in that one, or maybe you didn't?
Yeah, we went down November. Yeah.
Oh, okay.
Okay. Yeah.
Okay.
And then I think Jeff up in Minnesota. I can't think of his last name right now.
Jeff
Yeah. Jeff. Yeah. He has. There's proof of him sitting in it. There's photos online of him.
I don't have proof. No dated photographs.
There you go. But there's a couple of people have been down and checked it out. So I personally have not. I just decided to build one. So I need to. But cool. So, anyways, so that's that bit. Let's see. Since I'm here, let me go. I'm gonna stop my share and go dig up that YouTube video of the CX4 here, that crash that we had. Thank goodness everything's good there, but
can someone summarize the circumstances? The event?
Actually, let me read this to you, and I'll put the link in the chat here as well. But this seems to be the most up to date and has a quote from the pilot. So I would take that as being. Let me read this. I'll just read the beginning of it. It says it was a harrowing plane. I'll read the article. It was a harrowing plane crash captured on video, and now the pilot who survived it recalls the frightening ordeal. David Reeser, maybe mispronouncing that, spoke to Eyewitness News about the moment the small plane he was piloting crashed while attempting to land at an airport in Upland Wednesday afternoon. Reeser faced two major problems. The propeller of the plane flew off, and oil suddenly covered his windshield, forcing him to fly blind. Quote, it was a real surprise when the propeller went off. It came off the airplane, but I didn't have a sudden fear, he said. I've always practiced off-field landings or dead stick landings. Now I get to do one. It says, quote, Mayday, Mayday, I just lost my propeller. There's oil all over the screen, end quote. Reeser says in released audio tapes. Anyways, there's some more to it, but yeah, that's the gist of it. Let me pull this up, and I think we can play it in the video or the screen share here. We will try.
I've always wondered who's standing by to make a video of that.
It sounded like they were actually just flying
Maybe
over in their
tower or something. I don't know.
I thought
I think in the LA basin, you can't spit without hitting a news helicopter.
Yeah. I'm pretty sure they. It says something about their.
Well, that's the tail end of it.
Yeah, I'm still trying to see the shared screen. I lost it somehow.
Hey, Martin, go down there at the bottom and see if you can't pick it up in the tray.
The lip reading isn't working.
Can see it okay? Okay, all right, good enough. All right, I'll hit play. Sorry.
Not getting the audio.
Alan, you said you're not getting any audio?
Correct.
Is anyone else hearing it?
No.
Oh, okay. Let's see. I thought I had it set up so it would share the audio. Let me do this. Let's see. We want to use. Trying to see which audio. Switch phone audio. No, I don't want phone audio. Okay, well, anyways, I guess you guys have, I think everybody's kind of seen this one, but this is the link in this, I think I put this in the chat already. Let me.
Catherine's report.
Yep. Yeah, I put it in the chat already. So yeah, definitely go watch that, check that out. And there's the video is the one linked from that article. So has a couple of things from from David Reeser, who was the pilot there. So yeah, at first when I saw it, I thought, man, you know, it looks like maybe it was gusty or something. I didn't realize the propeller wasn't on, and then and thought, well, you can walk away from it. It's, it's unfortunate about the plane, but if you can walk away from it. But yeah, then hearing about the oil on the windscreen and the propeller miss, boy, that could have ended really bad. Thank God. So.
What's bad is 2 Rev Masters losing props.
We don't know it's a Rev Master, do we?
No.
Yep.
I don't think we do.
See it's published anywhere. Just
Yeah,
says VW
I've-
2400.
Yeah, I've been looking, believe me, I've been looking. I've not seen anything other than a 2400 cc Volkswagen. So it could be, but I don't
Hey,
believe
Ben,
it's published anywhere.
I just
Yeah.
put a full video link in the chat. I think that's
Oh,
the
okay.
full video from beginning to end.
Of the full,
Yes.
the landing there. Okay.
Channel,
Yeah.
Channel 7 or somebody's publication.
Gotcha. So, yeah, I guess I don't know, what were you guys' thoughts on this thing? I mean, obviously, I think we're all thankful he walked away from it. It's
Miraculous.
I saw him going over that semi truck. I thought, man, that could have been bad. Boy.
Yeah.
Well, it looked like there was quite a drop in elevation off the end of the runway.
Yeah.
So it sounded like he knew at the airport that he knew that berm was coming up and he didn't want to go beyond it for whatever reason. If was there houses, or I guess I didn't Google it yet to see. It sounded like it was in a densely populated area.
I haven't looked at the map, but it sounded like, yeah, there was like housing or something after there, or there was something he didn't want to get into. I don't know, was it water or something? I'm not really sure. Yeah, I'm just kind of scanning this article. I'm not really seeing anything, but I guess I've read a whole bunch of different articles about it. So, anyways, but
the comments that were, whoever made the comment about plane and pilot, because it was a good article, except the guy has no comprehension of energy management. So, I mean, he was trying to bleed off his speed, and he just ran out of runway before he could, get her back down on the ground.
He was lucky to be going fast enough that he could pop up over the fence. He did a Bob Hoover.
I assume that airplane doesn't have the dive brakes on it, or the air brakes on it.
One of his friends said that I think that he was using the air brake.
Oh, okay. I didn't know. I just was
One
curious.
of his friends had a good description, and it was in our publication there that gave kind of a synopsis of his what happened. But nobody seems to pinpoint the engine make and model and whatever.
let's see here. So here's from Mary Hardy. Says, this is my home airport. I've known the pilot for many years. Here's some context for the armchair pilots and wannabe NTSB investigators, straight from the pilot's mouth, which I kind of love that comment. But anyways,
yeah, she did a good job.
It says, lost the prop in flight, windshield covered with engine oil, terrible visibility. Came in too hot, tried to bleed some speed off. Remembered there was a berm at the end, figured that ground looping into the berm would be much smarter than ramming into it head on. Not impressed with his own performance, but he did survive. This is what's funny is that I showed him this video and he didn't even realize just how bad of an approach and landing it actually was. So apparently while he was flying it, it felt better than it showed up on video. So, yeah, I suppose so that must have been the deal. He must have lost enough forward momentum that he knew he was going down. He remembered there was a berm, so he was going to try to. I mean, you see him drop that left wing, and I thought, yeah, boy, that's a weird maneuver. If you're like, when I watched it, and I assumed when I first saw it, I thought it was just a bad landing. I thought it was an inexperienced, pilot. And
evidently, he's a very good pilot.
Sounds like it. Yeah, he's
with a lot of experience.
Yeah, but then you hear, oh, there's no propeller. So just right there, like what Glenn went through a couple weeks ago, right there is enough to say, okay, all bets are off. Adrenaline's flowing. Who knows how you're going to behave and handle it. And then, and you can't see. Like, holy cow. I mean, that's amazing. So, yeah, thank goodness. But a couple of things that I observed from the photos. I don't know if you guys saw these. I was going to call attention to. So the fuselage, there's a definite crick in it. It's bent, but it's behind the seat. So it's behind the wings. So I thought that was kind of interesting. So for as much torque as was on that airframe when he landed, it just to have that behind the seat, so that so that made me feel pretty good about the structural design of it. The other thing is, if you look at, there's a photo of it being lifted, and you can sight down the wings, and yeah, there might be a little misalignment, but it's not much for as much force as must have gone on that left wing. There's it looks like it's off by a couple of degrees, or it could just be the camera angle or something too. But that's pretty impressive to me that the wings aren't tore up more than what they are. So.
Well, the wingtip absorbed a lot of the energy.
Yep. Yeah, but
it would be very interesting if we could ever find out I'll use the term cause and effect between the oil and the prop failure. Try to figure out what caused what.
If you look at that Catherine's report site, there's a bunch of pretty good photos, and you can see the whole prop out is just simply gone. I think that's kind of, so I wonder if it's, I don't know, but I wonder if the crankshaft broke or something. So
the gone could be because you hit the prop against the ground and it could just snap off the hub right there.
Could be. It sounded like the prop was gone in flight though, and so.
Well, Patrick Stans has said that there's a single nut with a right-hand thread, and they have a tendency to loosen and back out. So I don't know, I don't know the construction of it.
So this is that crick in the fuselage that I was talking about. But I mean, it looks like it's held together fairly well. And then here,
probably a good thing.
When you sight down the wings, look at that. I mean, it does look like it's off a few degrees, but with as much impact, I mean, it's minimal. So I'm pretty impressed by that, honestly.
Yeah.
The other thing is the left wing tip is what hit first, so it makes sense that it crinkled. It's still attached though. So what I'm inferring from this is, if you were to hit severe turbulence or some in-flight issue, it looks like the wings aren't going to be the problem area of the airframe, right? Like you aren't going to lose a wingtip in flight probably. I mean, it looks like, that is a pretty rough crash, it looked like. So definitely stressed the airframe in ways that it wasn't intended to be stressed. So.
Hey, Ben.
Yeah.
Look at the speed brake on the bottom.
Let's see.
Yeah,
yep. It's there. It looks a little twisted there, but.
Ben, if you get a chance, go to your email. You got a picture of both twins.
All right. Let's see here. A picture of both what?
It's called both twins. The two planes are identical. They built them together.
Oh, okay. All right. Here, let me see what I can come up with here.
Because, I mean, other than RevMaster and Scott, nobody else is actually building engines. Sonics and Great Plains are just kits now.
Well,
Right.
Most of them are not 2400s, are they?
No. Yeah. I don't even know if Great Plains even offers a 2400 anymore.
In the documentation, it stated that it was a VW 2400.
Right.
The FAA documentation.
But yeah, Martin, to your point on the engine build, I think you're right. I don't think there's another VW-based builder. Nothing that I can think of anyways. Because there's AeroV, which is the Sonics. There's Great Plains, but both of those are kits, right?
Yep.
Correct.
And then the Revmaster and the Castler are, you buy it complete. I think that's it for the VW base.
There's
I'm
one
aware of
called
anyways.
Limbach.
Yeah, that's European. They're certified engines.
Yeah. And I think those are less. I don't know what the interchangeability is of components on those. That doesn't mean that there isn't. I don't know what it is. I took those to be a little bit different from a VW, kind of maybe loosely based on VW versus a VW base and then tweaked. But yeah, Harold, these are nice looking planes.
You
The
just say this.
reason why I'm saying this is David sent me the template for the shark's mouth to put on my own airplane.
Oh, cool. Okay.
And what he did is he sent me both of these, and he said that they built them both together and they're almost identical.
Right.
So I can't tell which one he was flying.
Yeah, I can't see that. I can't. Can I zoom in on this? A little bit, maybe. But it's getting. I was going to see if I could see that tail number, but I can't. Nice looking planes, though.
Looks like they have two different props on them.
Yep. One's got more skew than the other.
Yep.
Yeah, I can't tell though on this if the speed brake was down or even if it was down based on all the, the inertia that was put into it. If it might have been popped up, but it looks kind of twisted in this photo, but it definitely looks up there.
Looks like the landing gear's twisted too.
Yeah, this one's pretty bad, but. I guess the things I think about are like the cockpit area isn't collapsed or compressed, which means that it's to some degree that there's a good amount of strength in there. I think the design's good to protect the pilot in the case of something like this. I don't know, makes me feel pretty good about the design there.
I've been more worried about what happened to the fuel when I was sitting in the cockpit and couldn't get out.
That's a good point. So something did change with the geometry of it because he wasn't able to get out, right? So was that due to injury or is that due to something having moved?
Yeah, it'd be interesting to find out if it, was the plane just ended up in a attitude that it was hard to get out. Because, some people, we had a guy 20 years ago landed a Yankee in a tree, and he sat in a tree all night because he figured if he got out of the airplane, he was probably going to hurt himself more than if he just sat in the tree. And finally and rescued him. So, sometimes you get hurt more after the crash than during the crash.
Yeah.
At least in the tree, you'd be able to use a cell phone.
Yeah.
Are you on the ground? No, but almost.
I'll be there eventually.
Well, luckily the tree was inside of a highway, and somebody driving by the next morning saw him up in the tree.
Wow.
But that's what you get when you scud run at night in the wintertime.
Mm.
Anyways, kind of an interesting topic there.
With more information, it'd be interesting as, if Glenn keeps saying, the planes have like 13:1 glide ratio, well, with the prop, it should have been even a better glide ratio. So, how high and how far from the airport happened, And
I know Glenn asked, was this on takeoff? And so that's the question too. Like, how long is the runway that he was at the end of it before he got to the ground, right? So if he was on takeoff roll and he got up a couple hundred feet or something and then lost the prop, that would kind of make sense that he'd already have used up, half or 3/4 of the runway. Something on climb out, but yeah, I don't know anything about the Upland airport there.
I mean, the only thing I could think of is, how much can you side slip it? Because he had a visibility problem, so you might end up with a face full of oil if you side slipped it too much, I suppose. But
so I believe the photo I saw showed that he was going this direction and ended up somewhere down here, like where it says College Business Park. I think that's kind of what I saw, is that. So he was kind of going to the south, taking off, or I don't know if he was taking off or landing or what he was doing, but he was heading towards the southwest, and initial attempt at landing was somewhere in here, I think, and then he ended up passing this road here, Dewey Way, and then landing somewhere here. This must be that berm. Oh, there's a channel down here, and then a business park. Yeah. So that must have been what he was trying to avoid there. But
that water, are those ponds?
it kind of looks like it. Now, whether they're have water in them year round or not, I don't know.
Maybe dry ponds.
Yeah, they do look like ponds though, and it does say San Antonio Creek Channel, so that would maybe be a dry riverbed or something, but seasonal moisture in there, I don't know. But anyways, that's what I saw. Not to say it wasn't over this way or something, but there was a diagram showing the point where the plane came to rest was down here, is what I saw. So it seems to kind of jive with what we saw in the video. But
Is that a towered airport or not? I didn't look.
Looks like the tower
I do not know.
just north of the Deneen trucking.
It's a very big airport, but they might have enough volume to have a tower.
Let's see. Okay. Let's see. Do we have any AWAS? Fuel pricing.
Hello?
Hello.
Hello?
Harold, you're on.
I'm sorry. Somebody's trying to call through.
Oh,
Oh, okay.
no worries. Let's see. Killer report. Let's go over here. I don't really see. Well, anyways, all right. Let's see. Airport data, notice reports.
Just look for the frequency.
Yeah, I'm not seeing anything. Let's see. Yeah, no traffic control.
That's a Unicom.
So, anyways. So what else? What else are you guys up to? Alan's getting ready to start building, and there's a couple other people that are starting CX4s and other things. Anyone have any new projects they're working on, or any, Greg, what's your status? I saw some riveted together aluminum there, so.
Yeah, I had, there's one other thing I wanted to mention. A couple places, well, probably in all the CX plans, you end up with 3/4 angle that you need to rivet into. And boy, can you see the little mark on the end of this thing right there?
Yeah.
Okay, that's essentially how close you can get with a rivet head down on that. And it's kind of a little silly close to the edge of the angle where you'd normally want to be riveting further in. So I ended up making a little block out of aluminum actually, and shaping that so that you can now get that rivet head on there and be doing it a little more justice to exactly where you want to be riveting it. So this little block that I made was a real saver in that regard, because it made possible what really didn't look like it was possible. So that was the only little tidbit.
Greg, on that topic, what are which side is the thin? How can I say this? The head of the rivet should be on the thinner material, if at all possible, right?
Yeah.
That is
Okay.
That is
this?
Yeah.
And so in this case, is this one of the spars where the web goes on the inside of the angle?
Yeah. So
Or something like that?
all right, so interesting topic, and I've talked to Don Larson about this and Dave Thatcher, but Dave sent out that note that said, hey, there may be some difficulty getting 3/4 by 3/4 by 1/16 angle. This
Yes.
is 3/4 by 3/4 by 1/8, and so he said, hey, it's legitimate. It is okay wherever there's 1/16 angle called out to use 1/8. So in the construction manual, you see photos of these horizontal stabilizer spars with the full height aluminum and the pulled part of the rivet on this thinner back side, which of course, yes, it's preferred supposedly to put the rivet head against the thinner material. So in theory, you'd be, going back the other way.
Right.
Now, when you do this with the 3/4 angle, if you have the spar web inside of it, now this is 2 1/4, so it's out of proportion, but you end up with a significantly smaller piece of material going in on the inside. And so I chose, because of the thicker angle, to mimic the photos that were in the construction manual, and in lieu of trimming it down a good bit more to fit on the inside, to put it like they have the photos in the construction manual on the back side, if my little quick visualization made sense.
What is the reason that you're riveting
the other way?
Right. What is the reason that you're pulling them from the direction from inside versus outside? That's what I'm missing.
Because that's exactly the way the photos in the construction manual show it.
I think it's wrong.
I would agree. I mean, unless there's a specific reason, but that seems wrong to me.
Well, when you put in S1 and the 2 S3s, there's a real question as to how you can access that area. Especially attaching S1 and S3, you're definitely going to be riveting. Well, and in that case, you would have thin material on both sides. So it wasn't clear to me, and I'm not to that point yet.
I'm going to pull up the builder's manual here, and so we can just kind of walk through it here. Let me share this screen.
Say, a quick question, Ben. I'm on your shared screen on like a internet page for last 10 minutes, so I missed all that, and I cannot find any way to get off of it. Is there some way to?
Oh,
It's up above in green. It says you are viewing Ben's screen, but it's not what you guys have been talking about.
Apologies. Yeah, I'm not sure. Other than if you can, I don't know if you disconnect your video or something, or let me try just stopping and resharing here again. Although I've done that a couple of times. And let's just see if that clears it all. Is that any better or still the same thing?
Yeah,
Nothing. I'm not certain. Let's see. Trying to find the spot. Okay, so Greg, this is kind of the general area we're looking at.
Yeah.
Is this kind of what you're looking at here?
Yeah, it's that, and then there's a couple other. Let's see. Right there.
Here?
Right there.
Wow, yeah, that's weird, huh?
That's exactly what I'm set up to do, exactly like it's shown in that photo.
I mean, if there's not interference on the backside from some other joining component, I can't understand why you would do it that way. I mean, I understand that is there a description of that, or yeah, here's another one. Yeah, this shows no, is this I can't tell if this is the form head or not.
Some you can't tell, admittedly.
Okay, I'm going to go over to this. So this is on the CX4 community site. These are photos I think Jeff took. And let's go scan through here and see if we can see any close-ups of the tail section. See, like here, this is what I would expect. I don't know if you can see that, but these are those brace pieces, and they're riveted, through the thinner 40 thousandths material into the 3/16ths piece. Same thing as the skins here and so on.
Exactly.
That's what you would expect.
Yep.
And I guess I would say I would look long and hard, or talk to Dave for the reason that he did it that way. That is shown in the builder's manual, before I would do it that way, would be my recommendation. It just seems contrary to everything I've ever seen about doing pulled rivets. Yeah, I'm honestly not seeing anything in here. You can keep scrolling down slowly and see if there's anything else, but I don't think there's much on the tail here.
And you have some situations like where the S1 and S3 ribs attach between the two horizontal stabilizer spars, and you've got thin material on both sides. So that's just lose from the head goes on the thinner side, because they both are.
Right. Okay. Let's pull this up here and look at this again. Let's see. So you're building these spars right here.
Yes, those are the pieces.
Yep. Okay. So like with the splice plate, that makes sense. Okay. And here, yeah. See, in this blueprint, it shows the formed head being against the thinner material.
Mm-hmm.
Right.
Yes.
Or I'm sorry, not the form head. The what do you call it?
The head.
The head of it, yeah, and then the shop side would be the other side.
So there's two things going on now. You've got that shows it the way you would expect it. The photos in the construction manual show it the opposite. As shown in the drawing there, that's 1/16 angle. Mm-hmm. I've got 1/8 angle, and then a shorter or not as tall spar web because the angle's thicker. And so you clearly have two answers within the same set of plans.
Well, best practice is always to put the factory head on the thinner material. So unless there's a reason why, I would disregard and go by best practice.
I would agree with that. Yeah, or give Dave a call and just verify with him. But yeah, that's I would definitely agree with that.
Yeah, and I did touch base with him initially, and I will be calling again. Now, let me ask this question: Is it ever considered standard practice to have the pulled head of a rivet facing externally?
So you're talking about the head that you form when you pull it, right?
Yeah. Is it considered normal to have that facing externally to the aircraft?
I wouldn't think so.
I mean,
No.
maybe in certain cases, but I wouldn't think so.
Because essentially that aft spar of the horizontal stabilizer, yes, the elevator attaches, but on the gap on the inside, that is facing externally, and really that.
Oh, I see.
Is open to the outside, and I also have a funny little feeling about the appropriateness of the pulled head facing outside.
Yeah, I see what you're saying. So in this case, on the blueprint I have on the screen, the factory head, it would be external to the airplane. It would be inside. I mean, it wouldn't be in the airstream. It would be but it would be pointing outdoors.
Yeah, exactly.
Right.
Looks to me that would be an ideal place to put a flush rivet and solid ANs.
Solid, I would agree. I don't think the
bars.
Yeah, I think flush wouldn't be necessary. It's on the airstream, so it shouldn't have any effect on it either way. But yeah, the solid rivet, that would be totally fine there.
Question about the orientation of the piece. I'm thinking in terms of, did Dave build it the way he built it, as if those rivets were bolts and you were running bolts from forward to aft? Or have I got that backwards?
Well, it's shown in the blueprint here. Yeah, okay, so I see what you're saying, because with bolts, you would always want the head of the bolt to be facing forward,
right,
as much as possible, and any structural components. Yeah, so I think in this case, the orientation would be that the factory head would be facing aft. So the open end of, let's see if I'm getting this right. The open end of this faces, there's two angles. Let's see, I can't see myself on the screen here, so I don't know if you guys can see my picture or not, but oh, here, I think I have Greg's video pinned here. Let's do this.
Why is the web built on the inside of those angles?
I don't know. The only thought I would have would be that for some reason he wanted the that splice plate on the backside to be flush on the angle, but I don't know why it would matter if it was on the web or not.
So installed, is the open end of that facing forward or facing aft?
The open end of that would be facing aft.
Okay, so therefore that would go to look at the picture in the builder's manual. If he was thinking rivets simulate bolts, but they don't. So,
right.
I'm sorry, just trying to figure out, get inside his head after the fact.
No, that's all right. Let's see, pull rivet. I'm trying to think. Is it 519? Yeah, let's see. There's a spec on. Okay, here's this whole spacing, edge distance, that sort of thing. But I'm not sure if this is for pulled or.
Actually, what we're trying to do here is we're trying to derive the reason after the fact, which is probably a waste of all of our time.
Very true.
Call Dave and solve that question.
Yeah. Greg, are you going to reach out to Dave on that one?
Yeah, I did touch
Okay.
base initially, but now at this point, I need to clarify. But yeah, that's the plan. Yeah, and I'm honestly, I'm asking more than I'm telling.
So, Greg, after you have that conversation, would you post that in the groups?
Absolutely. Yeah.
Thank you, sir.
So, anyways, yeah, this is a good place to go for, of course, this isn't letting me scroll down for some reason, but
Follow the Bible.
here we go.
Yeah.
Let's see. But yeah, this is a good place to go for details of how to, okay, 425 or something. There's 420. Rivet identification. Yeah, here's this stuff. Let's see. This talks about the diameter of the rivet, the spacing of holes. This is for hard rivets. But I think this also talks about, maybe that part doesn't.
There you go.
Okay, here it talks about Cherry Max rivets. Yeah, self-plugging friction lock, bulb, Cherry rivets. Let's see.
This isn't talking orientation.
What's that?
This doesn't discuss orientation.
Yeah, that's what I was gonna see if there was anything that talked about which way.
Yeah.
No, this document doesn't. There was a separate document that talked about orientation of fasteners. I can't remember which one it was offhand.
Oh, sure. I guess what I was looking at was, well, I guess no. You're probably right, Alan. It's what I was specifically looking for is riveting different thickness material together, and which the orientation.
Okay.
So to your point, that might be in a different document. It seems like I had seen it in here before, but maybe not. There's a lot of pages and a lot of information, so it could be hidden in here somewhere. Anyways, but yeah, this is a good resource. It's great bedtime reading when you can't get to sleep. But
when all else fails, consult Tony Bengalis.
yeah, right. That's actually a really good resource too.
Yeah. Yep.
But anyways, well, cool. Anyone else have any other interesting thoughts, comments, questions?
Any update on the CX7?
Nothing since the last that we heard from Glenn. So sounds like the taxi testing went okay, and that's about all I've heard. I try not to pester him, so, but hopefully it'll be soon. And my CX7, I've been working on the redoing the center section spar. There were dimension issues we hit, and so I'm let's see here, go pull up. But anyway, so I started machining that anyways. So so hopefully I'll have that together before too terribly long.
Are you redoing it in the virtual world or actually physically making a new one?
Both, yeah. So I redid it in CAD, and now I'm machining it. So yeah, I've cut the web and the two flat bars, and now I need to get out my my jig for the angle and do that. But yeah, here I'll share my. I think I shared this last week, but I'll share this anyways. The CAD model.
Yeah. Where's your dimensioning incorrect?
So on the original plans, there were a couple of things. If you look at the builder's manual, or if you look at the original plans, this can you guys see my screen? I think I'm sharing.
I'm looking at a rivet.
Okay. Yes, I'm sorry. Sorry, Martin. But so these vertical pieces, these are actually on the outside. On the original plans, they're on the outside of the longerons. And so when I drew it up originally, these holes for mounting those, of course, were then flipped around to the back side. Then the other issue was from the center line to the outside edge of these lower and upper longerons, the dimensions were wrong. They were off like, I think 1/2 inch in one case and 3/4 of an inch in another case. There was one spec on the fuselage drawing and there was another spec on the center section spar drawing. And so anyway, so I had somehow reasoned in my mind to go with one of them over the other, and I did it wrong. So, so anyways, I went back and moved a couple of things, re-drilled some holes. I figured I could put in just bolts in blank holes to keep the, you know, the structure intact, everything no different than a rivet or something. But then I ended up having to redo it a second time, and then that's when I realized that I would have overlapping holes. In that case, that doesn't fly. So, so starting over. So I think this is going to be good. I've looked it over with a few people to make sure that the dimensions look correct. But anyways, that's kind of where that's at right now. And so hopefully I'll have this together by, I don't know, end of this next week or something like that. And then I already have a number of other parts for behind this cut and ready to go. So hopefully I can just bolt it together pretty much and then continue on my way with the next section of bulkhead and the rear longerons. So anyways, so it's been a process. But
are you drilling the main bolts for the spars as a complete assembly? You know, all 3 spars set and then drilling them, or are you drilling them individually and using a fixture to?
You're talking about all the rivet holes and bolt holes. So
when you get the outboard spars and the center spar done before you drill the final holes for the.
Oh, for the mounting bolts.
Yeah, the whatever,
Yep.
1/2 or 5/8 bolts, the main bolts.
Yep.
You drill those at very last.
Yeah. So what I'm doing is I've been drilling a, I believe it's a F letter size drill bit. I think it's F is 0.257 for the 1/4 inch bolts, the AN45, whatever they are. So these holes here, right? So I'm drilling all of these holes that the wing attach plates will mount to. I'm drilling those on my C machine on a flat surface. The actual wing attach bolt holes will be over here a little ways, right? And that those I'm basically center drilling them, but I'm not drilling them to size.
Yeah, they're off the end of.
Yeah,
they're not showing on there, but they'd be off to the left of those 1/4 inch bolts right now.
Yeah, let me show you what I'm doing here. Yeah, so like here's a spar assembly for the CX5. This will take a sec to open. So because I'm doing this in the computer, right? So I can set all my dihedral and everything in here. So you can see here's the center. Basically, for any of you who aren't in the CAD world, I can mirror things. So this whole component of like this, I think this would be the left wing. Yeah, so this would be the right wing. So we're looking at the front. Yeah. So, but anyways, this is your right wing, even though it's on the left-hand side. But this whole component I can mirror over here, so I'm not too worried about these locations here. But yeah, for the sake of this, you can see here's the wing attach plates, and the holes are marked in there. I'm not actually drilling them to size though, Martin. I'm not. I think that's kind of what you're asking, right? So I'm not drilling them to size. I'm just drilling them to 1/4 inch, basically center drilling them, so that you can put a pin through them or a smaller size bolt and verify your alignment before actually final drilling those and bolting them.
Okay.
Does that make sense?
Yeah, it's I had one of the earlier RV4 kits, and Van, the 4 has just two wing panels, and then they butt together in the center of the fuselage, and then there's heavy steel straps that tie the two spars together. And Van thought he was doing everybody a favor by drilling undersized holes in those steel straps.
Okay.
The real pain to line up a strap from front and aft side of the spar, and as you'd be trying to drill, it would catch, and I ended up with one egged out hole by a few thousandths. And then he finally just said, okay, I just won't put any holes in, and it was a whole lot easier than a pilot hole in there.
Interesting. I mean, I guess the other thing is with since I am, building the spar kits, I mean, they're matched. I could just, ream them to size and provide the bolts. The concern I would have though is that, variation in the bolt diameters. Since I'm disassembling it, if you don't have them matched up, you could be off by a thousandths or something like that. Because the specs for those bolts, even though they're AN, they're seems to be pretty loose tolerances as far as what I've seen. So.
Well, I think you're okay because you're only got one hole in each cap. You don't have 7 or 8.
True. Yeah.
So
You're not.
I think what you're doing will work. It's just that the discussion a few months ago with guys trying to find oversized bolts.
Yes.
The trick is to buy your bolts, measure your bolts, and then ream the hole to fit the bolt.
Right. Yeah. Do it. Yeah.
Right. And if worse comes to worse, then buy the oversized bolt.
Mm-hmm. Yep. Exactly. Yeah. Start from a position of way too small of a hole and work your way up to the bolt. So yeah. Anyways.
Looks like you did a good job.
Yeah, I mean, I've done a few of the CX5 assemblies here. Yeah, so I don't know if anyone ever has a question about how these things go together or different things. One thing that's like I always found very hard to read in the plans was how. So if you see the spar web on the wing, it comes down right basically flush with these wing attach plates, right? So the spar web and the upper plate, everything, it's all one big chunk of metal there, big chunk of meat that gets bolted through. So when I was first looking at the plans, so it was very hard to see that. So anyways, yeah, so that's what we got going on there. And yeah, again, this is the CX5, so there's one piece spar for the majority of it, and then there's this plate with a upper and lower. There's a splice plate with it, and then the upper and lower kind of reinforcing caps there on that section.
I think if you had a book of just a lot of screenshots like that with the splice plate, no dimensions, no nothing, just a screenshot, that would really help a lot of guys out over what's going on the plan. Yeah.
Well, I've been trying to get some of these drawings together on things. I haven't talked to Dave too much about, because I know there's a concern about publishing too much information and having people be able to build it without plans, without paying the money basically to Dave. But on the other hand, I think if we put out good information, then maybe people won't have such a challenge building it, and it'll be a little bit easier. This is a confusing drawing, but you can see this is just the dimensions of the major. Sorry, I'm trying to zoom in here. But the major bolt hole dimensions for the intercostals on the CX5 spars, so you can see some dimensioning things there. Yeah, I've been trying to put together some of this stuff just because in those plans it's showing dimensions not between the centers of the bolt holes, but between the edges of angle aluminum and stuff. And so that's great for somebody who's gonna clamp that intercostal on there and then drill through the intercostal and through the spar web or the spar cap. But when I'm trying to do it on the CNC machine, I can't do that. I need to know where the bolt hole is in advance, right? And so I think for some people this might be helpful. For others it might not be. But since the rivet holes are all just spaced 1.5 inches and then offset by 3/4 inch, those you place kind of, as you see fit. But I figured if you can get those intercostal bolt hole spacings correct, you're going to be in pretty good shape then. But there's a few other, every once in a while I try and spit out some drawings here. Attach plates, notched.
Well, I mean, just showing the picture like that, where it shows the relationship between the splice plate, the splice angles.
Sure.
I mean, that simplifies it for people. I mean, I'm used to looking at drawings, so but for a lot of guys and gals, that would be a big help, just to have a picture like that with no dimension.
Okay, yeah, I see what you're saying. So yeah, more so than.
I mean, it's basically a virtual picture instead of, or you could just take a photo picture too. But
yeah,
well,
yeah, I guess the thing that I like to see the drawings, because then I have dimension drawings. That's fantastic. But yeah, it's kind of nice to have the picture like this, or even better the exploded view, where you can see the interrelation of things and sequence of installation and that sort of thing. I will promise you this though, you will never see me modeling rivets and putting every single rivet in place. I might do some bolts here and there just to make sure there's clearance, but boy, rivets, I don't want to be putting in rivets. So
shock and disappointment, Ben.
Yeah, exactly.
That's why they invented the array command.
The array command. Oh, I don't even want to ask. All right.
You just draw
Otherwise
one, and then you just say, I want 10 high and 20 in a row, and
oh, okay, yeah, this is
all of them.
Yeah. So I have the pattern, which is different things like this, but I use that more for creating holes, not for distributing rivets throughout. Yeah. But anyways, well, cool. I suppose I should probably call this meeting on time here. Yeah, well, yeah, I have a lot of stuff waiting for me out in the shop today. And
what's your new schedule going to be now? For
what's that?
Night? What's the new schedule going to be for the Saturdays and Tuesdays?
So we were talking about this. I think for now, we're going to try and do it the first Tuesday of the month and the third Saturday of the month. And try and do that at least for a couple months going forward. So I will try to send out probably on Sunday or Monday, whenever I post the YouTube video, I'll try to have the new schedule and post that out to the forum, the groups.io forum. And I already took a note down that I need to have an event calendar on my website so that people can go to that and get the dial-in information, find out what day it's on, and that sort of thing. Potentially add it to your calendar. So, but
sounds like
the
a plan.
Yeah. Well, cool.
Good to see you guys.
Yeah, same to you, Rob.
Have a great weekend.
Yeah, you too. And Alan, if you want to stick around for a minute and chat, we can do that, or we can join up later. Or okay, all right, cool.
Now's the best time.
Okay, sounds good. All right, thanks, guys. I'm gonna stop this recording here.